Good evening. I hope all of you are doing well. Let me get my camera set up a little bit better here. There. All right, I've got a black screen here, but we will get to this and see if we can't get something done. So first off, I'm going to open up Maria. All right, so now let's close that because I actually do want to, bring that over here. Look at Maria assignment 2. I just want to talk about it for a few minutes because there's potentially some changes. First off, I want to apologize to you guys because I had set something up for Monday night, which would have been kind of a perfect timing. I end up having some problems where I was completely out of commission for two full days. And then today I'm doing this as soon as I get off work. So trying to get you guys, trying to help out what we can. So I just want to point out I'm not changing the due date, but I do have a mountain of things because I had intended to do a fair amount of grading this week, and I haven't done any. So I do want to let you know that I will not be starting to grade this until Sunday at the very earliest. So that, you could say, is that an extension? Well, maybe, I don't know. I mean, I have a policy in place, right, that it's not late until I start grading. So there's that. And I will make sure I get through all of the rework. I guarantee to all of you that all of that will be done. And I do apologize for falling so far behind in my grading. I wish I could go back and fix that, but I can't. So, with that in mind, so let's now concentrate on what we can concentrate on, because that's all we can ever do, right? We can always just concentrate on what's the next task in front of us. And the next task in front of us is to look at this. I'm sure most of you have looked at it a fair amount already. I've had several questions online about it. All right, so repeatedly ask the user for 20 integer values. So the difference here is actually I need to change this. And the reason is a negative value becomes much more difficult to sort. So we want to make sure that they're non-negative integer values. So that much I need to, in fact, actually let me give you some insight into my process. I actually use Word to do this. So I'm going to pull this off to the side, right? I think most of you kind of maybe have figured that out. So, that's number 1. I want number 2. What? Oh, God, I hate my computer sometimes. The computer is automatically set up to update everything. I didn't do this right. All right. And that's right. Okay. So I get to redo this whole thing. All right. For 20 non-negative integers. Okay. The program then prints out the integer separated by a space. That's a I should make this note. So when it says repeatedly ask the user for 20 non-negative, that's what I'm changing it to, non-negative integers. I guess I could leave values there, but integer means a value, so it's kind of redundant. So the answer there is that the person who's testing it, me, forces those to, I guarantee that those will be positive. Okay? They could be 0, and you probably want to make sure that you can handle the 0, but they guarantee to you that they'll be non-negative. This means that you don't have to deal with what happens if I put in weird punctuation, what happens if I, if I put in a negative number. And we'll talk about this in a second. Okay, so, and I'm going to put some points directly on here. This is worth 50 points, right? So, okay. Print them all separated by a space. And because they're all positive, I think we should be, I think you guys should be able to get that. So what I did in one of the videos, I think it might have been 5, but it might have been 4 as well. As long as the integer is positive, we can use the ASCII values or the Unicode values, they're the same, to print out those characters. So we can actually do that. And there is an example of that. And I'm trying to remember which video it's in. I don't know. And we will look at that. We'll look at that code in a bit. But first I want to go through the rest of this. So then you can sort them. You can use any sorting algorithm, or you can make up your own if you want. There's hundreds of sorting algorithms all out there. Most of them are derivatives of about 5 main ones. You've got bubble sort, you've got merge sort, and quick sort. Bubble, merge, quick. Why am I drawing complete blanks on them? Those are the main ones I would say. I'm trying to remember. There's another one that's not. So merge sort splits the list into 2 lists and sorts those lists, and then it does that recursively over and over again until it. So, and quicksort does something similar to that, except for it actually sorts things into separate lists as it goes. It's a little different. It's more complicated. Bubble sort's the easiest one to program. So, you might want to do that. I think bubble sort would mean, so you just go through and well, you guys can look up how that works. I would suggest probably doing a bubble sort. You can do anyways, it doesn't really matter. So one of the things that's cool about this here, let me pull this out. Sorting algorithms, and I'm going to go to Wikipedia just because I'm familiar with it. Oh yeah, it's not for sale. Okay, that's great. I think, right, okay, so we have tournament sort, strands, lots of these different ones. So here's our bubble sort. Selection sort, that's the other one. So selection sort is pretty interesting as well. Heap sort actually is really cool. Those are probably the 2 that I would add to the list of main ones. Is it selection? Or actually maybe it's insertion sort. And these are things that hopefully you'll learn it as you go along through your careers at school. For the most part, you don't have to really worry about them in the real world. I've never encountered them in the real world, but you can look here. There's different. These are doing changing, selection, insertion, exchanging, and so it tells you kind of the different ones. It's partitioning. Partitioning and selecting. So there's different ones. There's even one, actually, I think that's called the American flag sort, or sometimes just called the flag sort. That one's kind of interesting as well. So, but you can just go to bubble sort here. Like I said, it's probably the simplest code. And you can look here. We've got some pseudocode and some other things. And I'm not going to spend a lot of time thinking about that or talking about it. All right. Now, wherein with the last one, I was asking you to put in these text messages, like appropriate messages between different things, like asking the user for a number and then printing the number and those kinds of things. I'm not doing that in this one because you've already done that skill already. So, and it's hassle and it's tedious and it's actually not hard once you kind of figure out the rhythm of how it works. So. Which means, so here's the thing, right? When it says this, right, separated by a space, that means they should be on the same line. So, and we'll look, I'll look and see if I can find that example here once we get to this. All right, I need to assign points to these, don't I? So I'm basically just going to, actually the sorting part is hard. So I'm gonna go 10 points on 2, 3, and 5, 15 points on 4, and then I'll have 5 discretionary points, which is my normal setting. And then now, I do want to add one more idea here. If you accept negative integers, so some people have asked for extra credit. This is not extra credit, but if you accept negative integers, that's going to be worth 10 points. And then I can show you guys, actually. It doesn't really matter if I'm showing you this. And then also, if you accept, actually, get off bold. If you recognize non-integers, that also would be worth 10 points. Bold. And what happened there? That got weird. Just looks weird here. All right, so did not. I'm going to close this. Put a 2 on this. Save this. And then save copy, PDF. So I'm adding those 2 extra things on there. So some people would call that extra credit. I don't think of it as extra credit because extra credit to me means that it's different. It's a different credit. It's above and beyond. And although this is above and beyond because this is worth 50 points total, there are 20 extra points that you can earn. So you can earn up to 70 points on this. But it's only worth 50 points towards the total, so that you can figure out like a percentage. Although I don't need to talk about that. So I do want to talk about final grades just for a minute. Let me just. Yeah, I think this is good. Yeah. So what I'm going to do is I'll post that onto the website as the new requirements document that includes the points there for you guys. All right. So let me open up my Maria here and load. I think it was our loop example. Actually, it might have been our loop example that dealt with this. It was not. Okay. So then we need to upload another one. RPN decoder. Let's look at this one here. What was this? This doesn't have anything in the same line. So I don't think that's it. RPN calculator. Let's just assemble it and run it and see what happens here. All right, so I'm please input a value. And what kind of a value do I want? That's right. This is in, I think it's in hexadecimal. So let's just put in a value, 42. And put another value. Oh, that's right. Okay, 60, 50, 20. Okay. And so let me take this, I'll put it back in Unicode here. Boy, that got weird. Decimal. Oh man, I should have put notes in here. See, this is the reason why you put notes in, right? How did it halt? All right, so let's just go back to assemble. Instead of running, I want to do one step at a time. So 42. It stopped. It just stopped. Jump down to the end here. And output, and then halt. Well, what's 42? Isn't there an ASCII table here? No. Oh, actually I can look here. Yeah. All right, so this is the offset. So I know it's this one. I know it's this one. I'm pretty sure. So this is the last lab or last lesson that I did. So what's the difference here? Subtract cent. The cent was a sentinel. 21. Okay, so let's go back to the other one. Because I'm pretty sure this is the correct one. All right, so assemble. Let's go ahead and run. And let's do, oh, it's 21 what? 21 in hex. So here, let's go 22. Let's not go 22. Input a value, 60. And then 21. So it print out this. Is there something here for space? There's not. So this one can't be the offset. What is it? God, I have to go back and look at it. So you'll have to go back and read that or watch that video on this because I do describe it and do talk about it. And this is the exact reason. A perfect reason. Because even in your instructor, this was done about a little bit over a month ago. I simply don't remember what I did. I don't remember what I did and why I did it and what each of these different things are. So this says jump to the end, and then we add cent offset. Okay, so we subtract cent. We add cent back on. We subtract the offset to check to see if we've entered 0. And then we jump to oper. So we add the offset back on. We subtract add. And add is to B. Not sure what that means, but we'll come back to figure that out hopefully. And then we add 1. And then we store that back in, is this right? No, we should be in oper. Okay. Continue adding. Oh, that's right. This one was adding up numbers together, wasn't it? Continue add is here. count the subtractions. Oh, we were doing division, I think, right? Some kind of division. Oh, no, we had add, subtract, multiplication, and we couldn't do division. I decided we couldn't do this. Oh, that's right. Okay. So let's just assemble again and restart. And so let's go 6, enter, oops, enter. Oh, it stopped. So subtract cent. Oh, we want to do addition. Oh, no, in Unicode. So let's change this to Unicode. So we do that. And then let's do 6 and 5. Then exclamation point to end. And we operate, we got a 0. That didn't work out exactly the way I was hoping to would. All right. Okay, I'm gonna end this one, I think. But what you do is that's right. So subtract function, multiplication function, continue, multiply, and multiply. Maybe I did I do it in the add one here? Subtract 1 from my number, from my add. So then subtract 1 again from the B. How did I get to here? So let's look for that. Let's look for my add func. All right, so here's my oper. Right, okay. So it subtracts the addition. And if we look here at add is 2b. Okay, so now I definitely need an ASCII chart. Let's open it up here. ASCII chart, ASCII table, that's fine, this works. Okay, so 2b in hexadecimal, 2b. 2b is the plus sign. Okay, so it's looking for the plus sign in the oper part. It seems to me that I had a final on this one, wasn't there? Like a last guessing game. I did not. So we add the offset, which is 30. Because, oh, and that's actually really good. Okay, so here, if we look and we ask why is 30 so important, because hexadecimal 30 is 0. And so when we get an integer value between 0 and 9, now here's the issue that we run into. A little bit of an issue anyways. You have to know what you're working in, right? So you've got hexadecimal or decimal, and so you've got to deal with, well, if we're just talking a single digit, if I have the value 3 stored, it's just a 3. But I want to print that 3, and I want to print it in Unicode. I actually need to print the hexadecimal code 33. And so since that 3, I add 30 to it, and that's the same for 9 or 8 or 7, including 0. Right, if I have the value 0 and I add 30 to it, I still get this hex code for the character 0. So I know what to print. This can't be, I mean, it could be the one that's printing out the number here, but all right, well, let's try adding 2 numbers. So Let's add in numbers in decimal, so it's easy for us to do this. So let's go. Oops. 5. Okay. Instruction set. So if we look at our skip condition, that means the accumulator is greater than 0. It's going to skip. And we're looking for our sentinel. Oh, so we have to go higher than that sentinel. That's the issue. Oops, let me get this out of the way. Yeah. So we were not inputting them in decimal. They can't be. Otherwise, when we subtract that 21, and the 21, if we look here, 21 is the exclamation point. All right. So let's pick a bigger number. Let's go 39 in decimal. Oh, that won't work either. Let's input in hexadecimal and do 42 in hexadecimal. Okay. And now I want to do the no, switch to Unicode and go plus sign. I know, switching around. And now the exclamation here. And it output is 0. It should have went to the add, shouldn't it have? Subtracts the offset out of here, which gets us a number. Oh, then we know it's an operator. Okay. All right. So let's. I think one more. I think I'm starting to remember now. Okay. Everything's going to go in Unicode. Let's go 5 plus 4 with a plus symbol, then an exclamation mark. Still gives me 0. All right. Let's do a step by step. 5. Add the sentinel to our accumulator. So we had a 14 there. Can we go back? Okay, so we subtract the sentinel, so 35, because 5, right, plus that 30, that's how that Unicode comes in. All right, so then we subtract the sentinel, which is 21. So, and this is all in hex, so it'll be 14 hex, which would be 20 otherwise. And then we test to see if that's negative. It's not. And so we skip past the end, and then we add the sentinel back in because we still are trying to figure out what this is. Now we're going to subtract the offset, which is 30. So we get the value 5. And if it's negative, and the reason why we did that is because if you look here, these are less than the plus sign, the minus sign, and the multiplication sign, which we used as asterisk. Those are all less than 30. But they're greater than 21. So here we still have a positive, so we can go ahead and just do a step past that. Now notice here what happened. We jump to this next section because in assembly code, it always just goes to the next thing unless we skip one. That and no matter what it is, and it doesn't care about labels. Labels are only used for jumping. So remember that. Well, we can also use values. We can have values or variables, as they were. Memory locations is really what they are. Okay, so then we store this in num_a, but we store it with an I. So, which means that num_a is actually just the memory location, A0, here. So num_a isn't the actual number that we want to put there, but it's actually the memory location. So then we go ahead and do that step, and it stores the 5 there that we wanted it to. Now we're going to load that back. We're going to load up the num A, and we're going to add. That's loaded right here. It's also loaded up here, and then we're going to do an add 1 to that, and that now becomes A1 instead of A0, which will be our new memory location, right? And then we're going to store num A. And num A is actually stored right here. So we added 1 to num A. So we're going to move forward 1 so that as we store things, we're going to move forward 1 space each time. Okay. Then we're back here. We need to put another value in. Let's put the 4 in this time. Do a step. It's going to do the same thing, right? It subtracted that 30 from our 4, which was 34, and that's still correct. Oh, the Sentinel is 21, I'm sorry. So 34 minus 21 is 13. So we jump past the end, it's not negative. So we add the cent back on again, the Sentinel. Now we're going to do the offset. We subtract the offset is 30. Checking to see if it's a negative number. It's not, or not negative, right, below 0. That, meaning that we put in the wrong, a lower one here. So we're going to go right back in here. We're going to store this. We recognize this is a number. Let's go ahead and store it. And then, so we stored that here in that position that we moved to because we used the I. And then we load num A. So we can get that. Now it's, say it's A1. But next number the next thing we want to store is in A2. So then we store we add 1 to num A. And then we store it. And then we go back to our main loop. Okay, now let's put the plus sign in there. Okay, so the plus sign just got loaded in. It's 2B right here. Do a step. That's right. We subtracted the Sentinel. It's not negative. But this time we get an A, which represents 10. So we skip that. We add the Sentinel back on again. We subtract the offset of 30. Now this time, see, we notice here, FFFB, that's a negative number, right? Because we have 2's complement going on. And that's where things get really ugly. All right, so I have to double check to see if we can actually get a negative number here. But we now says, hey, this is negative. So let's go ahead and jump down. It's not going to jump over that jump. So we're going to jump down to Opper. All right, so now we add the offset back in. So now we know what our thing is. We subtract add, and add is 2B. So now we're checking to see if it's 0, because all we care about is if we should be adding. So this says if it's 0, skip the next thing. It is, so we did that because what happens if it's subtract? And then it'll check to see if it's subtraction, and then it'll subtract, and then it'll check the multiplication one. Okay, so it is addition, so now we're going to go down to our add function. Okay, so now it loads, it's going to load num A, which here is A2, subtract 1 from it, because it's 1 too high, and then we're going to store it back down. So now we're going to point at this one here. And now we subtract 1 again, and we have our second number, num B. So now we're going to store num B. And that's stored right here. Didn't change, but it did store it. Now it's going to load num A from here. And this is num A, so it's going to load that 4. It's going to add num B, but it uses an add I, which means it goes to here. It goes to where this is, where num B is pointing. And so now we should get a 9 in there. We do. We store that in num B, which is this position here. And then we jump back up to our main loop. So then it asks us for another thing. We put an exclamation point in here because we know that's our end. Now we're going to get, we subtracted, right, so now we're going to get a negative, we got the 0 value, so now we're going to jump down to the end. So we go down here to where the end is. We're going to output what's there. Oh, that's not what we wanted at all, was it? We want to output this value. That's the reason why it's having trouble. Load I num b, because b is pointing to the result. Then add the offset to it, and then output it. And we want our output to be on Unicode. See if this will work. It had a problem. Okay, let's go back to assemble. Let me put a breakpoint here, because I can, and I want to run it, and when it gets to the breakpoint, it'll stop. So 5, 4, plus, exclamation point. And it didn't even respect that breakpoint. But it did print out the 9, because it took this value here, 9, and it added the offset to it to get the 39. Now where it gets tricky, and it becomes very difficult to deal with, is when it's a double-digit number to print it. And I don't believe we have any of that offset. So here's the digital offset. So we are doing something here as well. We don't have some of the functions aren't done though, because I didn't finish them. Okay, enter a number greater than 100. That's 600. And instead of Unicode, let's go decimal. Now, guess a number. I'm going to guess a number 5. Oh, actually, if I remember right, we saved this target here, right? Let me go back up here. We stored the target. Store target, reduce target. So the reduced target was the one that we, where is reduced target? Store guess, reduce target. Oh, right here. So we go to reduce target. So we load the target and then we subtract prime. So prime was just some large number. I think it was 99. And then we're just trying to get that until it gets, we're going to, so we reduced it down. And eventually we're going to keep doing it. Oh, that's right. It continues doing the reduce. So it just goes back up here, it subtracts, does this. It just keeps doing the subtraction until it's beyond that. And then it's going to jump down here to adds the prime back on again, right? Because I got to a negative value. So then stores the target. So I got to figure out where target is stored. Here's target. It's not going to show me. I believe it's right there, but I could be wrong. Okay. Yep. It came back as a negative number. And so then it says guess a number. Let's try 7. Notice what it's doing here. It's printing that 5 back out for us. But the 7 is stored there as the value 7. So this is doing the exact same, this digital offset. It's where it's adding that 3. And the reason why it's doing the 0 there is because we're allowing for, so like if I put an 11 in, it actually figures out what's in that tens place. And you're probably going to want to do that. I'm going to say that the numbers will be between 1 and 99. So they could be up to 2 digits. Now, when I say separating by space, so space right here, what we did, remember down here, is we put in the hexadecimal code for space, which is 20. And then up here, when we're going along and we want to put a space in, we just load the space and output it. And actually, we'll put the space in. And that's how we're doing this guess number part and that kind of thing. All right, so let's try just putting in the 6 here, because that was our target. Hey, you guessed correctly, and then it actually puts all that in there. So there should be... all right, so this keeps going, and then it is eventually going to go return from reduce. So then that goes up here. And so it's going to print the guess. So what we want to do is find print guess. Okay, all the way down here. Oh, that's right. It's asking the user to guess a number. It does the input, it stores the guess. All right, print guess number. That's going to be down here a ways. Print guess negative function equals print guess number. So it loads the guess, which again is the decimal value. It stores target ones, and then it's going to keep going down, so it's going to go into this one. So it loads target tens. Let's redo this, and I want to do a step through this. Stuff is going on up here. Oh yeah, right, because it's printing out enter a number greater than 100. Eventually it's going to get to here. So I put in 600. So it's subtracting till it gets to that 6 value, and then it's happy, and now it says going to print out guess a number. And here we go. All right, let's try 11. Okay, so I'm going to type in the 11. It brings it in decimal value. Now, what I want to do is go to the print guess right here. Okay, so it loaded the guess. It stored the target ones. It's now going to load target tens. Okay, oh, we just got to here, sorry. All right, so it stored guess. We put it here. It then it loads target tens, which was here. Or that's what it's doing now, right? So actually, this is the one right here. This is our ones and tens. It's going to add 1 to this 0. Now it's going to store that back into the tens. It's going to load the ones and subtract 10 from that. And so we get a 1 now. And then we store the target ones. into this place. So this is the first digit and this is the second digit. And we are going to keep subtracting from this until we get a negative number. It's not negative, so we jump up here again. So now we subtract again. So we made a 2 go to there, to the tens place. And then now the ones place gets a negative number. Checking to see if it's negative. It is. It is. So it jumps down here to negative. It loads the tens place, subtracts ones from it, and stores it back in the tens place. Loads the ones place, adds 10 to it, which is now a 1 again. It stores it in the ones place. It loads the tens place. It adds the digit offset and outputs it. We got the 1 come out. Now we load the ones place, add the digit offset to it to get our 31. Then we do an output again, and we get a 1. And then we load new line, and now we go to a new line, so we can do a return from printing, which is up in that main function, if I remember right. But it's going to, it determined that it was greater than the number we're looking for. So we can just run it here and press 6. Yeah, see, this has a problem in it, doesn't it? Because it does not zero this back out again. So when we do, not positive, not print question, where is it at? Print the guess number. We loaded the guess, which is fine. But in this case, we assumed that the tens place was 0 to begin with. It shouldn't be. And so we should load that and zero it back out again. So we would have to deal with that, because otherwise this is actually putting in the wrong number here. Because this was saved improperly. All right. Actually, I think I lost you guys' stream, so I don't even know if there were questions or even viewers. There are nothing. There's no one there. All right. So I think I'm going to end this. And if there are any questions from you guys, I'm available to meet. And I'll try to watch my emails between now through Saturday. So most of the day, reasonable hours. I probably 9 o'clock to 10 p.m. something like that. I won't watch it closely, so you don't expect me to be right on it. But I will be in and out probably every couple hours or so, and then, but also the rest of tonight and all day tomorrow. The same situation outside of regular early work hours, less likely to respond quickly. But then also Sunday, the same kind of situation on Sunday. Now I might not be available on Sunday, so there might be longer gaps on Sunday. And then Monday as well, and grades are due on Tuesday. And typically what I'll do is I'll publish them to you right away. So you guys will know. I'll send out an email saying where the cutoffs are exactly on points, so that everyone is aware of that. All right. I think it's been a really great semester. And by and large, man, everyone is doing a pretty dang good job. I've been pretty happy with it. I wish I would have been able to meet most of you. Or I wished I would have been able to meet all of you. But that's just the nature of online classes. I never got to do that. But I wish all of you good luck in the future. And feel free to reach out to me if you ever wish to, for any reason. Hopefully it's positive, but if it's not, that's fine too. So feel free to reach out to me if you ever want to. And maybe when I send that email, I'll consider I might send my personal email as well. So because my Anoka Ramsey email might not be live forever. So just try not to sign me up for newsletters. That's all. All right. Thank you much. We will. This is the end of our semester, so I'll look forward to getting you guys all your grades. And I think you're all, like I said, most people who are turning stuff in are doing fine. You're not going to have a problem. And in the end, you're going to get a grade. And let me say this, at least a little bit about grades. I talked about it at the beginning of the semester. You want to get A's and B's, or you want to get A's in everything. And I understand that for most of you. But just a caveat to this is when you go out to get a job, they honestly don't care, generally speaking. So it almost for sure won't prevent you from finding a job. It might, just maybe, will change the salary that you'll be able to get, but probably not. So A's and C's, it doesn't make a difference. I work with people who I'm sure got A's through all of their schooling, and they're fabulous and they're wonderful and they're great to work with. And I work with people who I think got C's through their school year, their whole schooling, and they're fabulous and wonderful and great to work with. So honestly, it doesn't really make that much of a difference. And that's the way I view it, is in the end, you might think it's a disaster to get a B or a C, and yeah, it affects you when you're in school, but it doesn't affect you when you get out of school. It generally speaking, once you get a job, and after that first job, no one even looks at your grades. No one cares about your grades. They only care about, how good you are. And so focus on getting good, because that's the long-term goal. So, and I know it's hard when you're 19 or 20 to think about the long term. That's just the nature of being 20. I understand that. But think the long game. Think, where am I going to be in 10 years? Where am I going to be in 5 years? And when you think about that, then the grade becomes a lot less important. And that's just the way it is. So some of you will be happy with your grades. Some of you won't be happy with your grades. I think all of you will know why you got your grade you got. So, all right. Thank you very much. That's it. I'm signing off. Bye-bye.